In this video, I'm going to discuss determining an empirical formula and molecular formulas when I'm only given percent by mass composition of a compound. So let's get started. So before I can find my molecular formula, I need to determine my empirical formula. To do that, I have to convert my mass percents into mass, and then I convert mass to moles. Once I find the moles of each element present in my molecule, I divide by the smallest mole present. If those mole ratios don't give me a whole number, I have to multiply until I do get whole numbers. And you'll see what I mean by that in just a moment. In any case, this strategy will give you the empirical formula of a compound. So once you have your empirical formula, you can move on to finding your molecular formula. And you do that using the molecular mass or the molecular weight of the compound. The molecular mass of your compound must be given in the problem in order for you to figure out the molecular formula. So what you do is you find out what the mass is that is contained in your empirical formula. If that doesn't match your molecular mass, that means you need multiple units of your empirical formula to get to a molecular formula. So you're going to divide your molecular mass by the mass of your empirical formula to get how many units of your empirical formula need to exist in your molecular formula. So let's say I have this example problem. I have a compound. It contains boron and hydrogen only. And it contains 81.1% boron by mass. And I'm given in the problem it has a molecular mass of 53.3 grams per mole. Now I can use that for information to determine the molecular formula of my compound. So first I need to find my mass percents for every element present. Now I know that I only have 2 elements present, and I know they have to add up to 100%. So I'll take my 100%, subtract 81.1, and that gives me my mass percent of hydrogen. Now to convert those percents to actual grams, I'm going to assume I have 100 grams in a sample. If I assume 100 grams, my 81.1% becomes 81.1 grams, and my 18.9% becomes 18.9 grams of hydrogen. And now that I have my masses, I can convert them to moles using their atomic masses from the periodic table. The periodic table tells me if I have 10.81 grams of boron, I have 1 mole of boron present. So I can convert my 81.1 grams into 7.502 moles of boron. And I take my mass of hydrogen, divide by my atomic mass of hydrogen, I get moles of hydrogen. You'll notice my grams cancel, I end up with moles. So now I'm ready to figure out my mole ratio of my atoms in my empirical formula. So you always divide by the smaller number. So I have fewer moles boron than I do hydrogen. So I'm going to put moles of boron in the denominator. So I have 18.75 moles of hydrogen divided by 7.502 moles of boron. And that gives me a mole ratio of 2.5. For every 1 atom of boron, I have 2.5 atoms of hydrogen. But I don't want that decimal in my formula. So I'm going to start multiplying to get myself to whole numbers. So I'm going to multiply each number by 2. 2.5 hydrogen atoms times 2 gives me 5. 1 boron atom times 2 gives me 2. So now I have 5 hydrogen atoms and 2 boron atoms. You'll notice my ratio is still 2.5. 5 divided by 2 is 2.5. But now I've got whole numbers instead of that decimal. So now I've got my empirical formula B2H5. For every 2 boron atoms, I have 5 hydrogen atoms. So now I've got my empirical formula. I'm ready to figure out my molecular formula. Now to do that, I need the mass of my empirical formula. And when I add up the masses of 2 borons and 5 hydrogens, I get a total of 26.66 grams per my empirical unit of my molecule. So B2H5 has a mass of 26.66. But I'm given in my problem, I have 53.3 grams per mole. So I take that 53.3, I divide by the mass of grams for each unit, and that tells me I need 2 units of B2H5 in my molecular formula. So I multiply each subscript in my empirical formula by 2, and I get a molecular formula of B4H10. Anyway, I hope this discussion helps, and thank you for watching.